Hey guys, this is Harold L.R. Watkins back with another video. In this video, I will be demonstrating the graph implementation for the next milestone of my efficient analyze ride sharing simulator. I will begin with my graph.py file, which you have here. This represents the city map as a weighted directed graph inside the constructor, which you see here. I initialize an empty dictionary named adjacency list. Each dictionary key represents a location or intersection. Its value is a listed tuple, and each tuple contains a neighboring node and a travel time wait required to reach it. A dictionary-based adjacency list is appropriate because a city map is normally sparse. Most intersections connect to only a few nearby intersections instead of every location in the city. Here you see um, the add edge method, which moment right here, add edge. Um, the add edge method accepts a starting node, a ending node, and a wait. If either node is not already in the dictionary, the method creates a entry for it. It then appends the ending node and wait to the starting node's neighbor list because only the starting node receives the connection. Each edge is directed. A two-way street therefore requires one edge for each direction. Moving on to my file method that opens an external CSV map file. You're going to see load from file here. Okay, so the load from file method opens the external CSV map file and process it one row at a time. Each valid row contains a starting node, ending node, and a travel time. The method removes unnecessary spaces, converts the travel time into a floating point number, validates the data, and calls add edge to populate the graph. Reusing add edge keeps the loading logic modular and avoids duplicating graph construction code. The string method then converts the completed adjacency list into a readable format for testing and debugging. All right, let's move on to my um, map map.csv. This is the map.csv file. Each row defines one directed road in this travel time. For example, A comma B comma 5 represents a road from node A to node B with a travel time of 5 units. The reverse road is stored as a separate row. Moving to my simulation.py. All right, the simulation constructor accepts the map file name as a parameter. It creates a graph object, calls load from file, and stores the completed graph as the map attribute. This composition relationship allows the simulation object to contain and manage the city map while the graph class remains responsible for graph behavior. And we're going to end up running the test simulation. Uh, Give me a moment. Okay, so we have finally, I ran the test simulation. This script initializes the simulation using map.csv, creates sample car and rider. Let me hold on, doing something. There we go. Doing something wrong there. Using map.csv creates sample car and rider objects and prints the simulation map attribute. The terminal output shows nodes A through D, their directed neighbors, and their travel time weights. This confirms that the external CSV file was parsed successfully and integrated into a simulation class. The map is no longer hard coded, so the same simulator can use different city layouts by loading a different CSV file. Thank you for watching.